Good evening, and welcome. Oh, all right. We'll see how this goes and how this plays out. Technically, this is the first of the duels and duets. You can count the one that I did with Brett Steele in December, but that was really an intro to it. So the idea is, and this is something that we're planning to keep going for a couple of years, and then if there's something really substantial and interesting that comes of this, we may make a book out of it. But the idea is to try to focus a little bit in friendly conversation or hostile conversation, we'll see, so that's why we don't say in advance what it is. But to try to find out what is in the background of some of these topics. And again, some of the pairs make sense right away, some of them will not. The one tonight, Greg Lynn and Peter Testa, I think it makes sense in many, many ways. And I think the topic that they choose is machine vision, but I think it has to do largely with the role of technology, and particularly the emergence of machine vision, robots, and many other things in which I will say that Greg and Peter both have been true pioneers and very committed to it and try to deal with the problem what this has to do with the cultural design and not necessarily from the craft and technology. So in thinking on the intro, here we have Peter and Greg. In many, many ways, there is a parallel, I would say, in the relation between technology and aesthetics and effects, not different than what happened in the music scene. And when you think in Daft Punk, clearly how the technology impacted their music, but at the end of the day, how the creation of a genre can be related to it. But also there's a desire to rethink the notion of authorships. And also they are, in many ways, a duet. So that could be in a scenario, and this could be a possible way that this thing will go. And there will be agreements, but also I think there will be discussion about what is the role of this to propagate and advance the design agenda. And in many ways, I think both of them has been more on that side than, let's say, in the highly specificity of the technology, but much more in the uncertainty what these things will mean for the field of architecture. Now, in many ways, we can argue that a duel is much more interesting and elegant and fascinating. This, of course, is a duelist from Ridley Scott, and one of them is Harvey Keitel. And the setting is really amazing, and the hair and everything. So one would hope that each duet will unravel into a duel. Not so sure that will happen tonight. I really think it's not going to be more this. I think it's going to be more along the lines of this, what we're going to see tonight. I'm not saying who is who. I don't want to take sides here. So finally, he figured out the technology. All right, so with no further ado, I think Greg Lynn will go first, Peter will go second, and then they will go into the living room, and they'll take it from there. So please welcome Greg Lynn.
I only brought machines, because we're doing machine vision. And so this is a very bracketed conversation meant to give us some stuff to talk about. And for me, I thought I would do two things. One is putting the form back into performance, because certain things I'll show are high performance objects which have very little formal character. And I think people believe things like airplanes, automobiles, cars, robots, drones, that they're driven by some kind of, well, only architects would think this, but that they're driven by program, that somehow they designed themselves based on performance, which couldn't be further from the truth. And then the other thing is trying to put some performance back into form. And that's because as a kid with a computer, everybody thought I was just making shapes. And I always thought I was making things that worked and did work, but everybody thought if you used digital tools, you were a shape person, not a performance person. So I went back to 1999 when I was asked about animation by a kind of endless barrage of journalists. You know, like Metropolis magazine, all these magazines were still around back then, and they all were doing stories on digital things and animation, and they all said, well, if you're using animation, that must mean that architecture is going to move, that you're really doing a machine, because there'd be no reason to use animation to design a thing that didn't move, so probably all architecture is going to be a robot soon. And my attitude about that was, no, spaces are dynamic and fluid, and I'm using these tools to make things that specifically don't move. So I put a moratorium on architecture doesn't move. And I use this example of a sailboat in animate form where I said that a boat hull is meant to sail downwind, so it presents a flatter planing surface, and upwind it heels over to present a surface for upwind that doesn't slide, but the shape of the boat never changes, that you could have two or more directions in something without actually having to change its shape. So for 15 or 20 years, I, in a very kind of religious way, made sure nothing ever moved. And the tools would move, and I got very interested, like a lot of people, in CNC machines and making patterns with tools and getting tools to do work and looking at robots as kind of sophisticated carpenters. But there also was a thread of looking at robots just for robots. And this is the thing I thought that would be fun to talk to Peter about. So the first time I did it was for a show at the Vitra Design Museum where I knew Rolf Fellbaum had one of the best collections of robots in the world, and I happened to have a collection of Gundam toys. And so in the show, I exhibited about 500 robot toys and did this video with proof where we put robots in the furniture and kind of animated the furniture with what a robot family, how they might use the ravioli chairs in the show. That was the first thing I ever did that actually looked at a, you know, at a moving robotic thing. Immediately after that, for like a nexus of reasons I won't go into, I did a competition with Frank Gehry and Peter Arnell for Sentosa Island in Singapore to do this crazy development. And I didn't know Peter Arnell at the time, who I now adore. But Peter said, look, I mean, I'm going to filter out all the vulgarities, but the message was more or less, Frank is going to do Bernini, I'm going to do a giant robot, and Peter Arnell was going to do the branding to make this into the craziest destination that had ever been. And I was really shocked that Peter would think I was doing a robot. I kept telling him, look, I don't do stuff that moves. I don't think architecture should move. And he just said, shut up, we're doing fucking robots. So, but actually, it was Frank that convinced me. He said he had done a moving dynamic facade for Times Square for the building where the ball drops. And it was chain link, and it was for Disney. And it had these Disney characters that would push in and out of the chain link fence. And Frank said he'd always wanted to do a robot and that we were going to do robots. So we spent a good chunk of time, about a year and a half, developing this proposal for the Singaporean government where across the bay from the center of the city was this development, and it had these glass facades. Ooh, hold on a second. Never crossed my mind there'd be sound. And it had these glass screens that would at night illuminate and have images for across the bay, And during the day, they would rotate down 90 degrees and make shade over the plaza. So these kind of 100, 150 foot tall structures would move in some fashion on a kind of daily cycle. But anyway, it was the first thing I ever thought, it's first instance I knew of a kind of giant robot building. I now know there have been a lot of giant robot buildings proposed. But for me, being cast in this role of doing a thing that moves, frankly, by friends who saw that as a missed opportunity, got me to think a little bit differently about animation and motion. So, and this was, maybe close to, not 10 years ago, maybe 8 years ago, something like that. So I really I didn't acknowledge it at the time, but it spurred a whole direction, I would say, in my interest in things that moved. And the first response to that was getting things off the ground and floating. And I've got some different examples of that. This also was a competition I did with Christian Moeller for the London Olympic Park competition. We lost, it was us, Zaha, and Anish Kapoor, so it's where the big red tower was. But with Christian, I said, well, let's try to do a thing that moves. I'm just wrapping up this Sentosa thing, let's do a little something that moves. And so we made this golden dome with the load that we would build it in carbon because it sits on 3 Titan KUKA robots that can handle about a half a ton each. And again, it was a very quick idea, but Christian's concept was that it would have a direction and it would follow the crowds as they would move in and out of the Olympic Park. And it would follow them by rotating on a ring, but also tipping and lifting on those 3 robots as it would gimbal this thing kind of in 2.5 dimensions. At the same time, I decided to design a boat and to go back to the kind of earliest digital tools, the computational fluid dynamics and particle analysis. I did this with Fred Karubla and a number of French digital PhD students of all different kinds, studying everything from the sail plan to the hull to the foils that it moves on. And this we did the first time anybody's ever done an anything but a boat that has coupled aero and hydro forces, which means if you look at the red and the yellow, that's showing that there's pressure in the water as this moves through the water. And then these streamlines are showing the pressure on the sail as it moves through the air. So it was actually sailing digitally in a virtual environment. It also means that this pretty much was totally useless because digital tools, unless you have an expert to verify the tools, are useless. So every time we would set this thing off, well, I'll show you. It just was always a catastrophe. But it was an interesting experiment. The shapes of everything were molded both for the kind of interior ergonomics and also for performance. So this boat is highly performance oriented. But at the same time, designing a boat's very low-hanging fruit if you're a designer because boats are just badly designed. They have cabins, master suites, salons, like all these, they haven't really thought about what a boat should be since maybe the 18th century. So they tend to be high-performance objects that get hacked together by people that are engineers. And then when they start to get designed, the people come in with the wood and the brass and all that stuff. So, there are a few architects that did boats in the 90s, like Norman Foster and Wally's and stuff, but not a lot's happened with that since. So anyway, the big thing is that this was very performance driven, but every performance decision was then designed and formalized, and in some cases, even some formal decisions happened to have some performance consequences, which were beneficial. And again, this was like the 1990s, where you would set up a scene like this, and we had 64 computers running for, say, a week to get this one result. You wouldn't get an image, you would get data that you could visualize, but it wasn't interactive. This is what happens when nobody's driving a boat and you couple aero and hydro forces. I mean, every time it was some terrible accident. So in the end, they decoupled both of those things and worked on the sail plan, worked on the hull plan. But again, it was I think the critical thing is you're designing a moving object, like it's a projectile. So you're not designing a static thing, you're designing a moving thing. Every design decision affects how it moves. It's a very different world than statics. It also included studying the aerodynamics of things. So everywhere there's red is where you lose laminar flow, and you separate flow and you get turbulence, which holds things back. So we were even getting information like this, which we would then go back in and redesign and reform. I wouldn't say restyle, but reform, and then run it back again. So it was really about a loop of form and performance. Just because I'm here and the whole thing's carbon and it's Peter, I know we're not supposed to talk about carbon fiber, we're supposed to talk about machines. So here's a little interlude of making stuff. It was manufactured for, first you make a foam boat, then you make a carbon boat. So we built a lot of the interior, we built all the interiors about 6 months before the boat got built, and actually used that method to build it. So we would CNC molds, Duratec and wax and PBA, mold release them, laminate them, bag them, put a core inside, laminate again, then consolidate everything, and then weigh it all. So the interior with the carbon was, 80 pounds with paint, about 60 pounds without paint. Then Bill Chrysler, who's a familiar figure here, we did a trade. He cut the molds for me. I gave a bunch of Chrysler lectures around the world at kind of mining and infrastructure conferences. And we trucked those down, did exactly the same thing. What's, I think, the best argument for the most expensive material on Earth is the whole thing was built with that. Like, that's all the carbon that built the whole boat. And that's all the foam that went into the core. And that 50-gallon drum plus another 50-gallon drum is all the glue that went into it. So you could build a thing, kind of as big as a single-family house with materials that you could show up with kind of in one pickup truck or one box van. So super expensive material compared to like a balloon frame construction. But you use so little of it that you save money. So, and you save a lot of other things too. So we built the boat the same way we built the interiors. No metal, all glue. We 3D printed the most critical part of the boat, other than the engine that always fails, which is these elements. So the most critical elements are all 3D printed, mostly for weight. They're much fiber reinforced 3D prints are lighter than the equivalent aluminum. And then all tied together, like glued or tied, no bolting, screwing, nailing. Okay, so anyway, back to how the thing works. The interior of it was designed to roll around. I learned that from Philippe Starck, who designed a boat and had it put in his garden and called the boat builders and said, you need to put it at an angle, because aren't these things at an angle? And I thought that was genius. So on the screen, I always designed everything at 15 degrees one way or another, because the thing is barely ever flat. So you're meant to roll around in it. I won't go into that. It broke, and we found it on Craigslist. But so it's very, it's a very sexy boat. Compared to other boats, it's a very nicely, handsomely designed boat. It's also the fastest boat of its size in the Pacific Ocean. I mean, we beat up on gold medalists and everything all the time, and we don't even know what we're doing. It's just that design with high performance, really makes all the difference. It's not about skill, it's about the object. And you can see the way those chines are doing the work they're supposed to do. It's keeping the boat from flipping over end to end. It's keeping the spray out of the cockpit. So all those formal elements, which are unique, are also doing some performance work. So it's not like we put this into a black box and got a really fast boat out. It's actually that it was really all about the design and the form. It's really nice to win a race. It's really nice to win a race in a kind of sexy femmy boat that all the other boat people think you're a poser in. So yeah, that's a power boat that has trouble keeping up with us. So anyway, so that's the putting the form into performance. I'll talk now a little bit about, I'll just skip through, sorry, it's 16 minutes. The rotating interior of the boat, I was asked to do a very, very small living unit for a building fair in Belgium. And I realized instead of doing, I think what they wanted was kind of a furniture interiors type response to small living. And instead we built this RV house, which is a compact volume that you roll around to live on the surfaces of. So I guess you would call this a plan. This is a cut through it, parallel to the ground, with the house in a 90-degree orientation. And you can see that's a bed with nightstands and a headboard and a closet that's like a donut that rolls around in a container. That's that same thing, rotated 90 degrees vertically. So now that's a kitchen. And you'll see the bed folds up into the wall, like an old-time boat furniture. And then this is a kind of sitting room and dining room when you roll it again 90 degrees more. So that's the dining room table hidden in that pocket, and then below that is a lantern. So all the furniture is gimbaled and rolls up into the surfaces of the house, like that. So that's dinner. That's how it rolls around. We built a little robotic platform. I mean, we put it on a universal robot to study it, but to have a universal robot roll something as stupid as this around would be just a waste of capacity. So we built, this is showing kind of how the furniture appears and disappears into the surfaces. We built a little robot to move the thing around, and we also built a little interface so you could roll it. So just using touch OSC, we built an interface that would control these little stepper motors. And it gave us some insight into building custom robots and kind of building scale structures that could move. So that's a 5th scale model we did in Belgium. Went to Facebook. What's interesting is you take it to, say, any architecture school, and what you get back is a lot of problem solvers. Like, people will ask you right away, where does it go? Where does all the crap go when you flush the toilet? How are you gonna handle a cantilever? What are building codes gonna say about that? It's like all your friends are like your doubters, You take it to Facebook, and everybody says, can I get in it? How big can you make this? Can I have 10 of them? Like, we need, this is how we want to work. Like, how many people can get inside? Will it still roll when I'm in it? That's what you hear when you go to Facebook. I think that's an important thing for architecture students to know. You don't need to be, there's lots of doubters among your classmates. Like, you could be the one non-doubter. Because it was there in a very circuitous way and through other things, we got asked to do something similar at the intersection of the digital and physical. And I think what's interesting about it is it became a little robot. It is a company that treats stores like fulfillment centers. So you buy, let's say you want a dog toy, you can go on to Curbside, which is an app, which you should all download and use, and say dog toy, it'll tell you where there are dog toys at Curbside powered stores close to you. You buy that dog toy, somebody goes into the inventory, pulls the dog toy out of inventory, checks it as what you bought, transfers it from the ownership of the store to Curbside, runs it out to a tent, and they have a very sophisticated way of pinging your phone and making sure they don't drain your battery. They know when you're within a meter of them. So when you get within 3 miles, they pull your stuff out of storage. When you get close, they bring it out to the tent. As you drive up, they just walk it right out and chuck it in your trunk or put it in your back seat. And the average time is 10.7 seconds for a transaction, for getting the stuff. And this company is, exploding in success right now. But they don't have an identity, and the tents are the wrong thing for people to come in contact with. So they asked us to design them a physical identity for this virtual service. So we thought of a pin, and in it, there are, for real malls, there's about 400 in North America, but there's 1,800 Targets, there's 4,000 CVS's. So there's a lot of these things that need this identity. And most of the time, you're seeing these things at a big distance across a parking lot. So you need to be able to kind of wayfind to them. You could wayfind off your phone, but also to wayfind to the pavilion, the pin rotates and tracks where the direction of the signal is. So it's always facing you as you're driving in, and it's kind of piloting you in, and also changing color to match the color of the screen that you pick for your the background of the app. So again, we built a kind of custom robot setup that would move this pin and engineered how the pin would move with bearings and things, and then Curbside is developing the antenna technology. Actually, their super trick antenna is in the thing. There's one of them in Glendale at the Galleria. So if you want to buy, every store in the Galleria you can buy from. So, and they consolidate it all and give it to you as you leave. Okay, I really wish I could show you what else we're doing with Curbside, but I can't. The one other thing I thought I'd show is just we're playing around a lot with drones. The first thing you do when you get a drone is you do that impossible view. So for this residential tower, for the Ratkovich Corporation, they asked us to do a sketch for their investors and to kind of look at some due diligence of what they could do on the site across from LACMA. First thing we said is, can we use a drone? Second thing we did is try to get the impossible view, which I think is a normal thing you would do with a drone. But actually, there's so much more you could do with one than just get the impossible shot. So for the Venice Biennale, we were buffaloed into doing like a whole project, like a big project. So in Detroit for the Packard plant, and my attitude was, let's design the whole thing for robots. Like, people don't want to be in this place in Detroit. Robots want to be there. Let's bring the robots back to Detroit rather than the people. Because the owner wanted all these hipsters, like live workspaces, coffee shops, lofts. It was a nightmare what they were talking about. So we looked at Cedric Price and his Potteries Think Belt and the Detroit Think Grid, and reusing trains for libraries and lecture halls, reusing infrastructure of lifting and unpacking things off trains to make event spaces, using depots for educational facilities. We use that same attitude, only throwing into the mix the idea of autonomy and intelligent machines. To get mixed use, we compared, like, we could fit 2.5 Amazon fulfillment centers, 1.5 Apple headquarters, a half a Tesla factory, 27 markets, 10 museums, 3 free universities. So we tried to look at a kind of blend of uses on the site. Won't go into all this. But the kind of most interesting thing is we built, instead of elevators, a drone superhighway. So it's a 25-foot wide surface with a slope that drones, like, kind of everything from automated forklifts to moving decks to kind of big crate carrying or pallet and shelf carrying robots could navigate and circulate around the site. We proposed 4 corporate buildings and 1 civic building with universities anchoring it with these collaboration spaces that plug into those. And I'll show a little video of it. We flew drones to get the impossible views. And you know, sync that up with the motion of a camera on a robot. Then if this was just like 2 months later, I'm not going to bother. It was overly ambitious. So I founded a company with Jeffrey Schnapp and Piaggio a few months ago. We've got 12 people in Boston building machines for buildings. You know, land drone scale things that just make your life interesting. So in October, check out what we did. The other thing that we're doing is at a much smaller scale with Nike for the Salone. We're doing intelligent furniture that knows your body state and modulates your body state. And this is some thermal imaging from one of the pieces of furniture we're doing with Nike. So for me, this whole thing about machines, it's both looking at things in motion, which I never thought that I would look at, but more interestingly, it's adding performance to forms and shapes that bring a level of, let's say, dynamism and intelligence so you wouldn't normally have if you thought of things in a static fashion. So, thanks.
I took our topic quite literally, and it's framed it quite tight as well, but in a way that looks at it maybe from another perspective, so hopefully this will engender some discussion. I'm only going to present one project and then some work here at SCI-Arc, since we're at SCI-Arc. But before presenting work, I'd like to address the theme of machine vision as it relates to transforming protocols of representation and production in architecture, with the idea that perception is the first mode by which architecture becomes speculative. Just as objects make objects, new ways of seeing generate the next thing. So as we saw in Greg's work, as it really brilliantly demonstrates, machine vision is about to fundamentally transform not only what we see, but how we see, and also the role of techniques and logistics in architecture. So computational visual systems exist in parallel or oblique to a disciplinary history of instrumentation that we all know, from Brunelleschi's mirror to Alberti's window, and from projections to panoramas, and an architecture of seeing that cuts across 20th century art practices. But as opposed to becoming naturalized within this disciplinary history, I think it's more interesting to understand machine vision as breaking with it and existing side by side with human-centered visuality. So machine vision is effectively a different gesture towards the real that does not simply displace or supersede, but disturbs and disorders conventions of representation, which is really the area that I'm going to be mostly focusing on this evening. So machine vision may be understood as the media for the inhuman. It's neither human nor non-human, and it exists in a liminal, undecidable, inhuman space. Form and ground, recto and verso, past and future, foreground and horizon exist outside now of any ontological hierarchy. This flattening leads to a different vocabulary that's not involved necessarily in processes of cognition or recognition, and defamiliarizing the ways in which images and objects are constructed and perceived. These new optical regimes have the potential to provoke new aesthetics and themes for art and architecture practice. So I'm going to talk briefly about a project we did for a car factory that's designed to produce a specific car, the BB1 urban electric vehicle for Peugeot Citroën, that's mobilized by the Michelin active wheel, which is an in-motor wheel system that's shown here. That we didn't design the car, we actually are designing the fabrication systems and the actual factory itself around this basic typology of car. That Greg and I find ourselves working with mobility and designing factories is, I think, quite unanticipated, at least to me. 10 years ago, I don't know that this would have been a project of much interest. So why now? Material culture and technology have transformed in ways to make this a platform, I believe, for architectural speculation beyond high-tech architecture, but also a shift away from difference as a basis for architectural innovation. So from the outset in this project, our interest focused on superseding the grid as an organizing and spatial paradigm, and we were intent on casting upwards beyond high-tech, the high-tech shed, if you will, but also the late work of Le Corbusier for Olivetti's, here shown, Olivetti's Centre de Calcul Électronique outside of Milan that combines matte, slab, and organic forms, and of course the twin of this, which was Kahn's Olivetti Underwood factory with its self-similar elementarism. So I'd like to quickly summarize 3 key mutations instantiated in this project. So while it's part of a larger body of work, it was, I think, our experience with coupling robotics and machine vision that opened up architectural possibilities within what is typically a fully optimized shed like the Tesla factory or even, I would argue, Apple headquarters. So the first mutation is an inversion of object relations tied to miniaturization. So we developed a model of production and assembly in which the industrial robot is broken away from the industrial production or the linear production line, moving from the mechanical towards the nano and ultimately biochemical. So inverting the typical relationship, robotics are miniaturized here and shifted from acting only outside of objects, as you know from all of those car factory videos, that here they're placed within the mold or within the object and within the material field rather than operating outside of it. And this inversion radically compacts production of the car body within a series of spherical robotic chambers. The second mutation is typological and spatial. And working on this project, we came to realize that while this isn't a self-driving car, that within the confines of the factory, it could be designed to operate as an autonomous or at least quasi-autonomous mobile robot. With in-wheel electric drive motors and real-time machine vision, Once the chassis and wheels are assembled, the car becomes a mule carrying its own parts to a series of assembly and fabrication cells that can be rapidly reprogrammed. So, like in this image here, Sol LeWitt's loopy-doopy paintings, this could be understood to be a ground plan, or at least a plan for this kind of a redistributed production line that's, in this case, involuted and folded back into itself with endless possibilities to create a non-homogeneous model of space. The third mutation is at the level of architectural elements and syntax. So no longer tied to conventional tectonics and industrial logic, the architecture is, I would argue, quasi-autonomous, if not fully autonomous, and operating at its own scale, defined by its own metrics and proportioning. So the trabeated forms that we worked on here and shallow domes tie to new material logics and on-site construction logistics, which I won't go into here. This black composite architecture advances the syntax of Labrouste, shifting from iron and steel to a fiber-based architecture. And in our work, like I would argue Mies van der Rohe, technology, machines and robots are a conduit only to create an autonomous or absolute architecture. So speaking here at SCI-Arc, I've never really talked about some of this work, so I thought it might be fun. Also, a number of people here have worked on these projects, and that really do directly focus on machine vision and a restaging of conventional representational and design protocols. So with robotics, machine vision is potentially a retooled technology of design. And in the lab, the cloning of digital and analog workspaces offers an alternative path to simple representation and challenges, I would argue, the digital-analog distinction itself. So in these new scopic regimes, pattern recognition, dynamic processing of images and video, multiple and simultaneous projections collide with geometric mappings to produce other ways of seeing that have the capacity to generate the next thing. So Robot House is designed and accessed with software, robotic, and machine vision tools that have particular interfaces and techniques for navigating, creating, editing, and exchanging images. So this apparatus as a whole can be understood as a theoretical installation regarding the status of drawing, coding, modeling, and fabricating. So I'd like to quickly show an example from the most current work that we've been developing here at SCI-Arc in studios and seminars that directly engage machine vision again, and now at another scale. So here is estranging default protocols of digital modeling and rendering. This project begins with the détournement of early computer graphic experiments like the Cornell box, originally aimed at correlating digital and physical scenes. So where the Cornell box sought photorealism, this work operates across non-correlated or cloned digital and physical workspaces that are organized in superposition rather than synthesis. This non-correlated approach aims to play expertly with the increasing overlap in post-digital culture between the fictive and the actual, and what is generated by software and rendered in physical form. So in what David Rui has humorously called RoboPomo, we've begun a series of projects that, while not retrospective in any way or in any way nostalgic, investigate a deep digitality that aims to invent a new mode of vision out of the collapse of earlier visual and representational schema. So instead of a single point of view scanning image feeds, deep digitality is a multiplicity of points of view and matrices of vision. This workflow has been expanded with a focus last semester on the Piazza del Duomo at Pisa, which is also significantly where Le Corbusier first experimented with the relation between drawing and photography. So these masterpieces of medieval architecture, seen by many as a standard of architectural objects of all time, are what Michel Foucault called non-correlated, or objects of emplacement, as opposed to localized within perspectival space, that arguably it's through the redeployment or mobilization of these objects across his oeuvre that Le Corbusier discovered the free plan. So this is a kind of mobilization, and another kind of motion and mobilization in architecture. So in this project, we also mobilize and reimagine these objects. And the workflow uses proxy objects, high-precision robotics, depth mapping, projections, image capture, and manipulation in a looping workflow to produce new objects and images. Object properties are studied from different distances and points of view, providing details at multiple resolutions, using massive numbers of overlapping images, which we can control in this setup quite easily. So careful consideration is given to the particular typological, morphological, and syntactic elements that make up each of these objects, and how they can be mobilized in the creation of a new object, paying attention to part whole, part, and so on. So quickly, I'll just go through two objects here. Looking at the Campanile, tools are developed with a focus on data collection as the first stage in transformational or cloning process. The remapping of the object slowly transforms as its image acquires the new data and detail from its predecessor's mutations. So this multiplexing of the subject rather than the object extends to what we're calling a photic materiality, a fake or forged materiality that's not simply superficial, but embedded within the object. Finally, in this instantiation of the cathedral, which is the third object in the series here, is viewed as a super object made up of a series of nested multi-temporal objects rendered as simultaneous possibilities or as a form of quantum superposition. As described by the project team here, conjoined schemes are explored as vectors of two or more objects, triggering a wide range of perceptions and producing secondary axes of superposition. So in this case, the seam is not only geometry, but perceptual as well. Sets of re-imaging strategies are established following the geometric characteristics of the architectural elements, and these specific points of view are now inherent in the object. So work in this case incorporates animation, simulation, and emulation techniques that overlay digital and physical, actual and virtual representations to achieve specific architectural effects, shifts in resolution and scale. So this non-correlated approach aims to extend the discourse of architecture and its vocabularies in ways both perverse and spectacular. So to conclude this part, I'd just like to acknowledge that these are projects involving a large number of people here at SCI-Arc, and that these have been going on over a number of years and are building a kind of a culture around these kinds of questions. So to conclude, these workflows are echoed in other areas of cultural production going on around us. For example, they run parallel to cutting-edge film production techniques and workflows that move seamlessly back and forth across the digital-physical interface in real time, as for example, the robotic light box used to film Alfonso Cuarón's Gravity. And like this instance, and the example from fashion that follows, I would argue that our interest in machine vision is an instance of a larger engagement with bridging the digital and physical, which Greg also pointed out in his talk. So facileness with both the aesthetic and the technological, immanence and materialism, is emerging in vanguard areas of contemporary visual and material culture, exemplified here in Nicolas Ghesquière's current collection and campaign with Tetsuya Nomura. What makes this work relevant to this discussion is the idea that digitality and analogicity are addressed together as two modal conditions in parallel feedback and feed-forward loops, much like the previous example from the work here at SCI-Arc and the film example. Presentation and representation are happening at the same time and influencing each other without reducing one to the other. Arguably, this sensibility that Ghesquière describes as an embrace of immanence lies much closer, I would argue, to architecture's post-digital workflow and aesthetics rather than conventional couture. So I'd like to just play a short video clip and then we can go up on stage together. Great. Okay. Thank you. It's great to see all this new work from you that really opens up, I think, a whole number of new topics and new possibilities, and very exciting to see it coming kind of into the world in such a rush of things. I mean, if I guess one way we could think about these two presentations are quite different ultimately. Where would it be fair to say that your interests are in machine vision are really about an enabling technology for motion rather than the kinds of questions that I'm pursuing relative to representation and to design logics, and so how would you?
Maybe so. I think I'm playing it much safer than you are, in the sense that the language, the architectural language of things is actually getting simpler and simpler as things move more and more. And I think that's just me being too safe, frankly. Because when I look at LiDAR and, I mean, I'm just confused. Like when I see LiDAR, I'm not sure if it's a photograph, or if it's geometry, or if it's data. And I honestly, I would ask you you seem much further along than I am with that, like how to sort that out. Because for me, I find the language of machine vision, the geometry of it, I understand. The spatiality of it, I'm trying to think about, like if people and machines are in a space, how is that space going to be different? But the language of that space, I think that's, I mean, maybe, I feel a little old in that sense. Like I'm not so sure that's my problem. I've, to this point, decided that's not my problem, that I can't take that on. Because it seems really big.
No, it is really big, and I'm interested in taking that on in the context of, that's why I've split this into a practice pedagogical talk, and they're quite different. What I do at school and what I do in my office are really quite distinct, actually. And because I also think it is very complex, but I think it's where things are going to be going. So, or at least it's an avenue where things could be going that is full of interesting caveats and prospects. So for, I think, students, it's a really important opportunity. I don't know, I may be too old too, to incorporate that. And as you can see, it's not directly incorporating into our work. Although I do think that the idea of having these two things in parallel is really exciting and interesting. And that they can open up. Instead of them, let's say, having to be fused, that they can open up a space for architecture, qua architecture, in actually a very conventional way,
Yep.
right? That they don't have to be fused, that they don't have to be merged in an active way.
Well, I mean, for me, that's the big question, like how things will change when self-driving cars are in cities, and when your furniture moves around and your house is intelligent. That's actually not a question. I frankly look at that as just work. Like there's work to be done there. The questions seem fairly, not obvious, but discrete.
Right.
I think the whole question of how are we going to see differently when we start to look at the way the machines see, that's a really huge question.
Right.
And I don't see a lot of people formulating the question in an intelligent way. I mean, I'm very impressed with the spectrum of things and how, let's say, close things stay to familiar, meaning the geometric, space of Pisa, the photographic quality of some of the LiDAR. It stays close enough that I feel like I know what it is, but then all of a sudden it turns into something I don't know what to do with. And I mean, I think that's a really, it's not so frequent that things come along that you don't know what to do with in architecture. But I think machine vision and LiDAR is something that I don't think anybody really knows what to do with.
Yeah. Well, what about motion? I mean, you seem very comfortable with that, which a lot of us would feel uncomfortable with, as you were saying. That you seem very comfortable with the idea that you can have large parts of buildings or whole buildings in motion. I mean, that's very ambitious and complex, and I think very daunting. To me, it's very daunting.
Well, it's like a factory.
Yeah, well, our factory, we keep it,
It's like a robot house.
we keep it, contained in a way. I mean, it's kind of, it's coexistent. It's not, at the level of the art. The architecture, at least in our factory, is actually is stable, right? I mean, it's pretty fixed. Things can potentially reorganize, but at a much slower rate than, say, the robotic parts.
Right.
So there's different speeds and different rates of transformation and so. And I think going back to the Cedric Price stuff is interesting, that you would connect into that you would link that up. Especially, I guess, Transformer, right, which was a really fascinating experiment that really, unfortunately, never seemed to really be fulfilled, but was, I think, a really interesting proposition that one could pick up on today and work through, that we now have a lot of the technology now is available and relatively inexpensive. I mean, a lot of the stuff that we do is really not that expensive in terms of the actual hardware that's involved.
I think if the scope of architecture is, clearly diminishing. I mean, it has been for a long time, but it's diminishing, and the opportunities are surprisingly expanding.
Yeah.
I mean, if you take, the thing is, say, a company like Google, as much as they're investing, or Microsoft, as much as they're investing in the building and construction industry and fixing problems that architects have chosen not to fix. I mean, they see a huge market there to solve all of the litigation and all of the sloppiness of the construction industry. So HoloLens and there's a dozen divisions I know of at Google that are all looking at the construction industry. But they're looking to replace us.
Right.
As they should be, frankly.
Yeah.
But at the same time, they have Nest and self-driving cars and all of these intelligent systems that they look at the building as a kind of frame that gets filled with intelligent, interactive technology. And that opportunity seems massive. Like, how would you design differently? Just if you even just took an inventory of all of the Nest devices.
Yeah.
What would you do differently? There's so much that you would change that it really just seems wide open.
Yeah.
I mean, I'm very surprised people aren't just solving all these opportunities or thinking up all the new problems and solving all these new problems.
Yeah.
Which frankly, that world of Silicon Valley is oblivious to.
Yeah.
Because they think of architecture as static,
Right.
you know.
No, back, I don't know, about maybe 15 years ago, we did some work with Herman Miller in which we proposed a project that we called Everywhere, that was a kind of a precursor to that, thinking about all of this stuff.
Yep.
And the fact that it could really be, it was wide open 15 years ago, even more so.
Yep.
But there wasn't, I think, a platform that there is now with computing, the internet and so on, was still, that was, 1999, 2000.
Yep.
So now there is the kind of networking that can bring those things together. But there isn't an architectural kind of proposition there yet.
Right.
Not any that I'm aware of.
Well, and also, by the way, urbanistic,
Right.
infrastructural, transportation, ownership. I mean, all of that stuff is for the, completely up for grabs. And all that stuff would have been the domain of a Corbusier.
Yeah.
So, but it's,
Well, that's your domain now.
I wish. No, but I think for the students.
But I think I sense that you're going into that world. I mean, that I sense that you have ideas about that, and also techniques and an aesthetic. I mean, an aesthetic for that world.
Yeah, I don't think I have an aesthetic for that world, frankly.
The beginnings of it.
I have an aptitude for the geometries of that world. I
Uh-huh.
don't have an aesthetic. I mean, that's one thing I know I have a huge deficiency in is there is an aesthetic for that world that nobody's getting near. I mean, if you look at the Google self-driving car, it's like that Larry David movie. It's,
it's really.
it's hilariously off. But no, it's because just nobody's thinking about it. I mean, but I kind of believe that's because we're not behind at all. I mean, all of this stuff came out of architects. It came out of Nicholas Negroponte. It came out of Cedric Price. I mean, and they were, by the way, also entirely right. Like what Cedric Price said would happen to Detroit in 1972 is exactly what happened to Detroit now. It's just I don't know what it is, the follow through or something wasn't there.
Well, but those also are such big projects, and that there was nobody, I think, to take that had that kind of political will and kind of ambition.
Well, at least now for us, it's good to point out that Cedric Price called it.
Yeah.
Might give us more credibility.
Yeah, no, that's interesting. So, in terms of these, the Piaggio, you're not able to tell us give us any hints?
No. No. No, look, I would so love, because it's at the point where we don't know what we're doing, I would love to show you all of the bananas experiments. Because they're fun, but I can't. Because actually it's a business. That's unlike a lot of stuff. I mean, that'd be stupid of me to show you.
Okay.
But anyway, it's fun. I mean, they're robots, but it's thinking through the environment and thinking through infrastructure the way an architect does, which is what's different than the way a car company or motorcycle company would.
Yeah.
And I think that's actually a norm. I mean, if you look at what a lot of the mobility and transportation companies are doing, they're really looking at cities as urban planners. And they're looking at buildings like architects would and figuring out, if you have an electric thing, it can go inside. So what do you do if all this stuff can just drive around in your building?
Right.
I mean, all over Google X, they have these funny signs that say, combustion engines not allowed, electric engines welcome. So, everybody's thinking about what happens when your car is in your living room and all that stuff.
But so, like for the students, I mean, these seem like the opportunities, like the world is opening up in all kinds of fascinating ways for design. I mean, it
One would
truly
think.
is, right?
Yeah.
But how do students begin to start to hook into that? How do you see that in terms of the way we're architectural education?
You're provoking me. This is where it goes to a duel.
Hey, I gotta try to.
No, but then I say depressing things.
Oh, no, don't say depressing things. Say positive things.
No, but I
about it.
can't. I have no positive answer for why architecture students don't do that. I think it starts with high school guidance counselors who detect tragedy or maybe unrealized tragedy in students and say, you should go to architecture school. That's a great place to cultivate tragedy.
So are you then thinking, would you argue that these are now ID scaled projects, but they lack the vision, right? That there's not a spatial
It's quick to go in at the vehicle scale or like with Curbside at the kind of kiosk pod scale. But it's getting much bigger, let's say. It's getting to a giant building scale.
Right.
So I think that's a good point of entry, probably.
But like, for instance, at Piaggio, are you hiring architects?
Uh-huh.
Okay.
And firing.
So and firing them too. Okay, but
No, some doesn't work.
but that's an interest, because I think these different models of
they're
practice.
great. No, they're great.
Yeah.
You know, at Nike, they're all architects.
Right.
From CEO down, they love architects there because they think strategically, they think
Right.
materials, construction, performance. That part's really good if you give a discrete task. It's just amazing in Austria, where our students are spectacular designers, spectacular. I showed them the Curbside thing, and they know me. I mean, they've been with me, most of them, for 4 or 5 years. The first thing they did was a litany of why it would never work in Europe. And I just had to laugh. It's hilarious. Like, how do you get a whole room full of people with the future coming at them like a freight train, who sit there and tell you how they're not going to get hit? So, and that's the dilemma of architecture.
Yeah.
So it really is a kind of, they always see the negative.
Chicken Little.
The Chicken Little?
Chicken, the sky's going to fall down.
Yeah. But anyway, so you made me be depressing. The room is now absolutely
I do
depressed.
think that it's an important, topic for us at this point. I think to really engage the question about, all these new opportunities. You seem to be bursting with ideas. I've got a lot of ideas too. And I see the possibility for implementation in a way I didn't 10 years ago, right? Things are beginning to open up in different ways if you keep at it, right? But I think that students don't seem to have that perspective yet. I don't know that they're seeing that or sensing that world out there. Do you, at UCLA in the program that you're running there, is that something that you see as a different model of education or studio, or is it more, as you were saying before, architecture is a great education no matter how it's taught, more or less. I mean, obviously it can be better or worse, but the format of studio and the learning that goes on and the thinking, the way of thinking is what counts, rather than tuning it towards a specific series of applications or opportunities. What do you think?
Well, I might be, maybe I'm being too narcissistic, but I thought there was a lecture at UCLA the other day where I thought Mark Mack was taking a shot at me, where he said to
a duel?
Aaron and Guvanch and for faculty, he said, well, you just don't have connections like the last lecture. You got to go get connections. And I took that as a slight. But it's true that with the MArch 2 program at UCLA, I've always gone, I mean, I shouldn't talk out of school, but like say the university would say, go get money from Boeing, or go get money from Disney. And my attitude was, no, I don't want the money, I want the CEO. Because if you talk to the head of real estate at Disney, who I know 3 of them actually that have been there, their job is mitigate risk. Like somebody tells them we're going to build a park in Shanghai, the head of real estate's job is to make sure it stays on budget, it opens on time. If any of those things are off, that's the end of their job. If it goes well, not a big, no big bonus. If you talk to the CEO, their thing is Universal is nipping at our heels. People aren't going to amusement parks, they're on phones. How do we make our parks more like a video game? How do we get people's devices integrated into the parks? Their job is innovation. And if a CEO doesn't innovate, then they get fired. So they have a totally different pressure on them. They're looking for new ideas, they're looking for new approaches, they're looking for new technology. They're hungry for that stuff. The mid-level is just trying to eliminate risk. So it is true in the MR2 program, we put the students with CEOs and CTOs and people whose job it is to innovate. And frankly, from those companies, I don't let anybody talk to the students whose job isn't on the line if they don't do something new, because that'll kill their confidence. So I think that's a unique thing, and I do think you have to identify the people whose job it is to keep things moving, rather than identify the people whose job it is to keep things from going sideways, which is usually who architects end up dealing with.
Right.
So I think that's very important. You've got to get over the head of real estate to the boss of the head of real estate.
Interesting.
But I learned that from Peter Eisenman and Antoine Predock. I mean, I learned that from architects.
Right.
I mean, they always were like, you know, everybody shut up for this meeting. Like, this is a meeting we're just going to get out of. But at dinner tonight, that's when we're going to do our work. Or we're going to talk to somebody on the side and get the people in this meeting on the right track, because otherwise we're dead. But all the architects seem to know that was important. I think that generation has maybe changed a little.
Yeah. Interesting. Yeah. I don't know if, should we open this up to questions? Is that appropriate, do you think? Yeah? What do you think?
Except I can't see.
I can't see a thing either, but yeah.
I hear them.
There are people here.
Thank you for your talk. My question would be a comment and a question. It would be that Peter Testa, you talk about the future and the possibilities of thinking about different things, and it seems that how you approach certain things with fabrication, but it seems that you're more interested in the pedagogy of the machine vision, and whereas Greg, you talk about people are not asking the right questions in terms of machine vision, but it seems that your talk is more the version 2.0 of this better form follows the same function. And also, you talk about solving new problems, and it just feels like not a duel or a duet, but a D-Day of machine vision on architecture. If you don't believe in machine vision, or if you don't think machine vision is the solution, then you're obviously not part of the near future or the future. And also at the same time, I would say that don't you find it worrying as to educators that you've problemized architecture, and architecture just became a problem-solving issue? Does it rotate or does it not rotate, and does it give the right effects or not? And I just wonder if it's about creating a huge factory, or what kind of pedagogy that's trying to challenge the importance of architecture versus the importance of machine vision, instead of what machine vision can do within architecture, or what they can do together.
Polemically, I would say your rhetorical questions, all answers are yes. No, because the biggest mistake I ever made when I was maybe your age, is I got into all this digital technology, and everybody said to me, nobody's ever going to use a computer to design a building in our lifetime. Engineers will use it. Nobody's going to ever sketch with a computer. And I really thought, like, I got a lot of time. I thought I'd kind of kick back on maybe worrying so much about the digital stuff, and I'll not so much give it away, because I think it's healthy to give stuff away. But I thought there was a lot of time. And then there people like Peter Pran came along. I'm like, whoa, what's a Peter Pran? Where is this guy from? He seems to be doing these funny blobby buildings in Minneapolis. And then SOM and the corporate firms, and pretty soon everybody was doing digital technology. So are you saying, will I be a dinosaur if I don't think about machine vision and if my rooms don't rotate around? Probably. Most likely, yes. I would say there's a very good chance. I mean, you know who the biggest opponents were? Was Stephen Hull, who said, I'll never stop watercoloring. He still watercolors, but he does everything on a computer. And the best was Billy Chen and Todd Williams. They were the most against the computer. And now I've just been reading articles about how they say, hey, this computer is an amazing thing. We all use computers now in our office. So, yeah, I would get rolling and machine visioning as fast as possible if you want to stay relevant. There'll still be people that'll want like a pencil drawn thing, but I don't even think Billy and Todd do that stuff anymore. There's pockets of it. But I think architects have to engage technology more rapidly than most other professions. I think if you don't, I think you could probably be like a Hollywood agent without a cell phone, maybe. But I don't think you can be an architect and not engage technology.
Any other questions?
I just want to know, how fast is the catamaran go?
28 knots so far. But we don't know what we're doing. That was with our cruising sails, actually, so we haven't really started racing yet.
That was kind of like 42.
Yeah, well, that's twice 28.
I've got a question that I think is probably more for Greg, but maybe you both have thoughts on the subject. Greg, you're guest editing the next issue of Log, and I was reading the call for submissions a while back, which I think is not on the website anymore, but if I remember correctly, it ended with the phrase, makers need not apply. And so there is a shift from the idea that architects might use robotics to physically make things and move more in the direction of directing robotic systems and other forms of computation in buildings. Can you talk about that shift in your work from making to directing?
Well, no, the RoboLog was meant to be provocative, and so using machines to fabricate and making robotic carpenters and welders and masons, it's covered. Some of the best minds in the field are working on those problems, so I just felt like they also seem to have endless issues of AD special issues, and that it was covered. That those people had their thing, there was no need to devote a RoboLog to that, just because it's so ubiquitous. But that's, I think that happened real quick too.
Yeah. 5 years or so.
Yep. Yeah, world moves fast.
Mm-hmm. No, at least the point of view, I think, when we initiated here at SCI-Arc, the robot house, was really about non-fabrication.
Yep. Which was very smart. I mean, I told you that when it opened, I thought.
Yeah, I remember you did. Yeah.
My question and comment, and probably we should go later after, is not so specifically about machine vision or robots per se, but technology at large. One of the things which I always felt, both of you and Greg, which I no longer, I actually can't believe I know you for almost 20 years now. The obsession about what is coming next, which I always think is a healthy thing. I just find right now myself in our schools and many other schools that they praise themselves about being involved in technology and so on, that there is a level of perversion rising in terms of produce a series of nostalgic approach to the use of technology, which I find incredibly strange. I mean, it's not only in the field, but at large, and also it's a nostalgia about something that they were not part of it. So the things move so fast that 20 years in technology already start to produce their own nostalgia and stylistic, nostalgic things. And I wonder how we can get out of that, because I find it incredibly perverse in the worst kind. The kind of, I'm not saying that by default ethically technology is associated always with evolving, but it should be. And I find the way that we started as a discipline, which always we like to do that a lot, we finding ways to perverse that, to technology to become reverse, as a way to revisit mistakes that the discipline did in the past in a kind of a different way. So I want to hear your take on this. Not that there is a solution of it, but why we want to abandon projects way before we figure it out what they can be. And we move into some, and usually when we abandon that project, is always to look back and tragically and enjoy, go to the past as a way to solve every time that we cannot figure out something, how we move forward.
What I'm scared about from tonight is that I don't have a take on the aesthetics of machine vision. And I think there's a tolerance for, perversion's a wrong term, for compartmentalized aspects of your life. So the same people that are doing the self-driving car are like curing meats and making, pickled vegetables and
Yeah, the Portland, the 1890s.
yeah, it's unbelievable how people compartmentalize their lives.
That's an American kind of thing,
Yeah.
though, right?
Yes, it is
Very
actually American.
thing, yeah.
But like I saw Jonathan Ives' house that he designed. It's like, holy crap. I mean, unbelievably, like Victorian. It's not like an iPhone. So there's a tolerance for that I think it's important to just say that just doesn't go. Like Jonathan Ives just can't live in that house. He can't drive a Bentley. A few people say it, but they say it and everybody forgives him for it. But I mean, I could never own an Apple product after seeing the Bentley at his house. It's just ridiculous. It has no credibility. And I think the same thing goes for somebody that's making a self-driving car and pickling in their garage. It just doesn't go. It's not okay. No, they should be 3D printing pickles. I mean, I know, I'm just worried that my version of not looking for the aesthetic that goes with machine vision is my cured meat hobby.
You're pickling. You're pickling.
No, because there's a really
You're
huge
pickling
tolerance
hobby.
for that stuff. And
Yeah.
I do think it's probably
true.
our job and culture to say, it's just not okay. You
Right.
can't live in that house. You have to get out of the house or it's the end of your company, because it's just not acceptable. You have to walk the walk through all aspects of your life. And I think that's what I find the oddest. And I think it's tough for architects because it is almost like anything goes. Like maker, I mean, what does that mean?
Yeah. Yeah, no, it is an American thing. That you sense that someone can have, extraordinary knowledge, for instance, about music, but then show up without any taste in clothes, right? That seems to be, the compartmentalization. So developing an aesthetics that crosses over is very difficult in America. But it's interesting. It's an interesting topic, an interesting set of questions. But I think tinkering with those tools and looking at them in relation to existing the architecture that we already know, right, or think we know, or have a way of understanding, is a way of expanding that space and entering that space. And at least that's the take I'm pushing. Rather than trying to do something using that to make something that we've never seen before. So that's not nostalgic, I don't think. I think it's moving forward. I don't see that the RoboPomo isn't nostalgic. I think that's actually. Okay.
No, but one of the first things you have to do with something that you invent is solve a previous problem.
Yeah, you
better.
have to go back and work on something that, and also that other architects have worked on, like the Corbusier's worked on that problem. So what does this bring to the mix, right? As opposed to heading off constantly into new territory, which you have no way to evaluate or understand. So I think that's one way of dealing with the question of the machine vision, or at least that was one setup that we thought might be a way for us to enter that space.
Yep. But I had a very formative experience. I mean, I know I've probably even said this in this room before, but when I showed Rolf Feldbaum a chair that was made out of thousands of pieces robotically cut and assembled, and he just said, you know, okay, one more idea, because otherwise you're retardataire and I have no business talking to you. Like, to come to a thing that's made out of 12 parts and tell me you're going to make it out of 10,000 robotically cut ones, you know, you're an idiot.
Yeah.
And he was right.
Yeah.
It was the stupidest thing, it was the most embarrassing thing I'd ever done, is to say I'm going to use a digital tool to make things pervertedly complicated.
Yeah.
And I think there's a lot of that around. Like, the minute you say machine vision, everybody gets all complicated. And that's, you
You
know.
gotta watch out for that. Yeah.
No, I mean, it's because they're not actually saying what the problem is.
Yeah.
Like, if I would have said, Rolf, I would like to destroy the business model of your company and introduce unforeseen inventory, labor, storage, shipment, all this stuff, then he would say, brilliant solution to that problem. That's not my problem. But the fact that I just showed up like, well, technology means I have to make this out of 10,000
Right.
things when I
Right.
previously made it out of 12, that was just dumb.
Yeah.
So, but yeah, people get in the weeds fast, I think, with technology in architecture schools. Probably not in engineering schools, but
Thank you, guys.
thanks.
So